Well, children, today we'll start with chapter 3, which is based on laws of motion. Now, while studying the previous chapter, that was motion in one dimension, you studied about the position, distance, and displacement and acceleration of a moving particle. Now, in this chapter, which is based on the laws of motion, you will learn about origin of acceleration or force, the cause behind the moving objects, that is, what causes the objects to move, the theory of motion based on the ideas of mass and force, and the laws connecting these physical concepts to the kinematics. Now, let's start with what is force, which most of you are aware of. You all know that when we push or pull, we are said to exert force on the body. So, this is a picture which is showing you a push or a pull exerted on a body. Now, children, it is not that force is only push or pull. That is, push or pull applied on a body does not exactly define the force in general. Force is defined as an influence causing a body at rest or moving with constant velocity to undergo acceleration. There are many ways in which one body can exert force on another body. For example, stretch springs exerts force on the bodies attached to its ends. Even the compressed air in a container exerts force on the walls of the container. Force can also be used to deform a flexible object. Now, children, the forces which are responsible for all the interaction between particles and objects can be divided into two categories. They are contact forces and non-contact forces. So, let's discuss in detail what exactly we mean by contact forces and non-contact forces. Now, what are contact forces? Contact forces are the forces that act between two objects that are physically touching each other. Okay, so remember, they are physically touching each other. And in this category, we have reaction force, tension, friction, and air resistance. Even the muscular force is in this category only. Now, first let's see what is the reaction force. Now, over here, can you see this table? Right? Now, on this table, there is a block kept. Now, the weight of the block is, you can see, is acting in the downward direction. It is shown over here. It is acting in the downward direction. And that means this block is exerting a force on the table, but this table will also exert a force on the book. That is the reaction. So, we can say an object at rest on a surface experiences reaction force. For example, a book on a table, or you might be sitting on the chair. Then there is a reaction on you by the chair. You exert a force on the chair and the chair exerts a force on you. The second category of force happens to be tension. Children, this comes into play when you hang things on a rope or chain or spring. Then there is a force which comes into play on the rope or the string or the chains. Now over here, can you see there is a rope on which there is a block hanging? Can you see this block? Right? Now there, the weight of this block is acting in the downward direction. So this weight will be pulling the rope. So there will be an equal force on the rope in the upward direction, which is known as the tension. So we can say that an object that is being stretched experiences a tension force. For example, a cable holding a ceiling lamp. Now, the weight of the lamp will be in the downward direction and the cable is going to experience a force in the upward direction. That means the tension. Now, see over here, the definition says an object. By object, basically it means that they are talking about whatever thing you are hanging an object with. For example, this object might be a rope or a spring or a chain, as I was telling you. So basically, tension, remember, is a force which comes into play whenever you hang things on a rope, strings, chains, springs, etc. Okay, next is the friction. Now, can you see a slope in this diagram? So now this, on this slope there is a block which is going to move down. Now the weight of this block is acting in the vertically downward direction and this slope is exerting a force on the block, which is shown in this way. This, I hope you remember, we have just done. This is the reaction. Now when this block is moving down, there will be an opposite force which will come into play, which will oppose the motion of the block. This happens to be the force of friction. It is in opposite direction to the motion, and this will be when there are two surfaces in contact. So that is why this is also a contact force. So two objects sliding past each other experience friction force. The objects may be moving or at rest, friction is always there. Next is air resistance. You must have observed things in the air. Over here you can see any kind of thing which is falling in the air, then there will be the weight of that thing will be acting in the downward direction and there will be a resistance offered by the air, which obviously will be in the upward direction. So an object moving through the air experiences a air resistance. For example, a skydiver falling through the air will experience some kind of air resistance. So I can say that when contact force acts between two objects, both objects observe the same size force but in opposite directions. Now let's see what are non-contact forces. Obviously, non-contact forces act between two objects when they are not physically touching each other. In contact forces, there were a physical touch. Here there is no physical touch. The examples or it in non-contact forces include magnetic force, electrostatic force and gravitational force. Now let's talk about the magnetic force first. A magnetic force is experienced by any magnetic material in a magnetic field. You all know opposite magnetic poles attract each other. As you can see, these two magnets north and south are facing each other. So there will be a force of attraction between the two. And like poles repel each other. Here you can see two north poles facing each other. So there is a force of repulsion. Now see, over here the two magnets are not in contact with each other. There is some distance between them, but still they are exerting a force of attraction or repulsion. So this is a non-contact force. Electrostatic forces are similar as to magnetic forces. It is experienced by any charged particle in an electric field. Now, opposite charges again attract. So, if you have positive and negative charge, even if they are not touching each other, they are away from each other, there will be a force of attraction. Similarly, like charges, that is negative negative or positive positive, repel, and if they are even away from each other, there will be a force of repulsion between them. Last is the gravitational force. This you all are familiar with. This is a force experienced by any mass in the gravitational field. You know, masses are attracted towards each other by gravitational force. So if you view this, there is Earth shown and there is a satellite. So there will be a force of attraction between the satellite and the Earth. Apart from this, you all know there are all bodies, they fall towards the Earth. You know, they fall due to the gravitational force of the Earth. So again, gravitational force acts between two bodies when they are away from each other. There isn't any contact required. Now finally, I can say types of forces are contact forces, non-contact forces. Contact forces, interaction between objects that touch. Applied force, I told you, muscular force, spring force, the tension, drag force, the air resistance, frictional force and normal force. Non-contact forces attract or repel even from a distance. We have three things in it: magnetic force, electric force and gravitational force. Now let's see what are the important properties of non-contact forces. These are action-reaction forces, that is, they are mutual. Gravitational force between two masses does not depend on the medium separating two masses. Electrostatic and magnetic forces depend upon the medium separating the two charges or the poles. All of them obey inverse square law. This is a very important thing and acts along the line joining them. Whereas electrostatic and magnetic forces may be attractive or repulsive, gravitational forces are always attractive. Now, before we move on, this inverse square law, remember, this means that force is inversely proportional to the square of the distance between two. That means the force of attraction or repulsion between two magnets will be inversely proportional to the square of the distance. Likewise, it is for charges and the gravitational force also. So remember, force is inversely proportional to the square of the distance between the bodies. These forces are long range forces. Now let's talk about the Newton's laws of motion. Newton had given three laws of motion. First law states that a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. Now see this, there is a ball over here, right? Now this is at rest and it will remain at rest, right? Because there is no force acting on it. But this ball, when you give it a kick, then there will be no force which will be balancing the force exerted by the kick, and this ball will be set into motion. That means to this ball continued to remain at rest, but once you apply a force which is unbalanced, that means it is not balanced by any other force, then this ball is set into motion, and an object, this ball will remain in motion with constant speed and same direction, again till some external force acts on it. So over here you can see, again this is a net due to which there is a force exerted which is not balanced by anything else, and this ball can be brought to rest by this unbalanced force. Now over here I have used the words unbalanced force. So let us first find out what exactly we mean by unbalanced force. Now see, can you see this block on the table? You already know that there is a downward force acting, which is going to be the weight of the block, and there is a upward force exerted by the table on the block, which is the reaction. So that means there are two forces acting. There is one in the downward direction, which is W. There is another in the upward direction, which is the reaction. And this is, in this case, W is equal to R. So this happens to be a situation of balance forces acting on a block. Under this situation, the block is not going to move because the two forces acting on it are equalizing each other. So this is a situation for balanced forces. So I can say that if the resultant of all the forces acting on a body is zero, then the forces are balanced forces. Like in this situation, the resultant of the two forces R and W will be zero. So this is balanced forces. Now let's see what are unbalanced forces. Now in this situation, can you see, here we already know that this force and the upward force, right, R and W are balanced. But apart from this, you can see there is one force acting on it, which is F1, given to be 120 Newton. And there is another force acting in this direction, which is given to be 60 Newton. This means the net force acting on it will be how much? F1 minus F2. F1 minus F2 will be 120 minus 60. This gives me 60 Newton. Now, this is a situation in which this 60 Newton happens to be acting in this direction. So obviously the block is going to move on this direction. So this is a situation of unbalanced force. To move a body, remember you need a force which is unbalanced. So if the resultant forces acting on a body is not zero, the forces are called unbalanced forces. Now coming back to this again, we know that this ball is not going to move because there is no unbalanced force acting on it. In this situation, the ball experiences an unbalanced force, so it is set into motion. And here again, this is basically again an unbalanced force is there acting on the ball, so the ball is stopped. Now see what is happening. That means there is some kind of resistance offered by the ball either to move or to stop it. So remember, an object resists a change in their state of motion. The tendency of undisturbed objects, whether they are at rest or moving with uniform velocity, is called inertia. Now see, over here, what are we saying? We are talking of all kinds of things. We are talking of the bodies at rest. We are also talking of the bodies which are moving with uniform velocity, and we are saying that they have a tendency not to be disturbed. So the tendency of undisturbed, that means a body at rest or a body moving object will resist any change in their state, which is known as inertia. Hence, we can say the first law of motion is also known as the law of inertia. Remember, greater the inertia, greater will be the force required to bring the change in the state of rest or of uniform motion of the body. Now, we need to remember that mass is the measure of the inertia of the body. So, heavier objects have more inertia than lighter objects. For example, a ball of 2 kg has more inertia than a football, and it takes more effort to kick a 2 kg ball than it takes to kick a football. Another example is, even a small child can push a toy car. However, an adult also can't push a loaded vehicle forward. So, Newton's first law of motion gives us definition of force. It says that force is something that changes or tends to change the state of rest or uniform motion of the body. Let's talk about some real life examples of Newton's first law. The best is when you take a journey in a bus. Now suppose you are sitting in a bus to go somewhere and a bus suddenly starts. You all know that the passengers sitting or standing in the bus will tend to fall backward. Now, you might have not even thought about it, but there is so much of physics involved in it. This is due to inertia of rest. And how do we explain it? Now, when the bus suddenly starts, the lower part of the body of the passenger, which is in contact with the bus, moves along with the bus, while the upper part of the body tends to retain its state of rest due to inertia. As a result, the passenger falls backward. Similarly, if the bus is going in one particular direction, then you know what happens if it takes a sharp turn. Again, you tend to fall on the sides. This is due to inertia of direction. Your whole body along with the bus is set in a particular direction. But when the bus takes a turn, the lower part of your body moves with the bus, whereas the upper part continues to be in the same direction, so you tend to fall. And if the driver suddenly gives a brake, then you all know you tend to fall forward. It will be a situation something like this. When someone is riding in a bicycle and he collides with some kind of a rock in front of him, he tends to fall forward. Why will he tend to fall forward? Because his lower part of the body comes to rest, whereas the upper part of the body continues to be in motion due to inertia of motion, and he tends to fall forward. So here we have three types of inertia: inertia of rest, inertia of direction, and inertia of motion.